Okay, so let's go ahead and get started. So today we're going to do some Git version control and collaboration, just kind of going over GitHub. As of now, we're pretty much done with what the university considers required material for the class. So from now on, I'm going to kind of be throwing things at you that could be useful in your career. We'll see some examples maybe here and there, things that you can set up like GitHub. Next week, I'm planning on doing a short demo on how to install Linux, things like that, how to properly set it up, how to fix common issues. I'll be doing it in a virtual machine, so it's going to be a little bit different than you installing it on your laptop or somewhere on an actual computer, but it's the same idea. So we'll go over some things like that, maybe how to do some bash RC aliases, functions, things like that to help you set up your environment, how to do your Vim RC, stuff like that will be next week. But this week we're going to go over Git a little bit more in depth. I'm going to go over the first homework. I'll kind of hint at what we're going to do for the third homework, which will be assigned sometime middle this week or the end of the week. So then you'll have a week to do it. Basically from now on, go to the next slide anyway. From the rest of the semester, I'm not really going to be focusing on labs anymore. We probably won't actually have any lab assignments anymore. We'll just have quizzes on Wednesdays for the rest of the semester. And that way we get enough quizzes in. They're just going to be reviewing what we've had so far. I'll announce them ahead of time. We will have a quiz this Wednesday on makefiles. I sent an email about that on Friday. So just a reminder, we will have a quiz today or Wednesday. So basically the rest of the semester, no more lab assignments to expect other than maybe one makeup lab assignment that replaces your lowest grade. So as far as makeups go, you'll have the choice. You don't have to do them. They're optional. So if you missed a lab or you don't like a grade that you got on your homework, I'm going to give one makeup lab, one makeup quiz, and one makeup homework. Those three are optional, but they will replace, if you complete them sufficiently, replace the lowest grade in each of those three categories. So it gives you the benefit, if you missed a lab, you can replace that lab. Or if you didn't do so well on a homework or a quiz, you can replace that lowest one. So those will be coming soon. Like I said, so as normal, there's office hours today from 2 to 3:30. Again, quiz on Wednesday, so show up to lab on Wednesday. Once we're done with lab or the quiz, you can basically leave. Unless you want to work on the homework or whatnot, or want to ask for help or something like that. I'll be there sitting in the lab. I might be grading some things here and there, like quizzes. But yeah, so you had a question?
Is the weight accurate in Dropbox?
Yes.
Okay.
So your grade in Dropbox is at a 70. So we've done homeworks, quizzes, labs, and your midterm. So that adds up to 70% of your grade. So if you divide whatever your course total on Dropbox is by 70, that is your percentage that goes towards your final grade that will be entered in. The other 30% is the final. So yeah, if you want to know your course total in the class so far, divide your course total on Dropbox by 70. It is accurate. Homework 2 is due on Friday. That's just building off of the lab 2 weeks ago. You just explain what my solution does, maybe add some inline comments with the hashtag or pound symbol, and then write a short summary of what everything does and then turn it in. Not too bad, I hope. So don't overthink it, just write a summary, put some inline comments for each line inside of the scripts, and then it should be relatively quick and easy, maybe an hour. So homework 3 will be assigned. We'll go over it at the end. Again, there's 2 weeks of lecture and lab left. So after this week, there's 2 weeks left. So you'll have lecture lab next week and lecture and lab the following week. And then the final is it. So today we're doing Git version control and collaboration. Next week, like I said, I'll teach you how to install Linux, how to set it up, how to customize it, put some bash RC, stuff like that. That'll kind of help you with the next homework as well, the homework 3. Then we'll have a week purely for just reviewing for the final. Yeah.
There's no like lab this week that Wednesday's off. So is it just Monday?
Oh yeah. Okay. Yeah. Yeah, you're right. Thanksgiving. Yeah. So anyway, so there you go. You don't have a lab anyway. Anyway, so we'll have a review for the final, and then we'll have the final. So the final is just going to be multiple choice and a lab, basically. So I give you the 60 multiple choice. You do it online, whenever, and then the lab, you basically come into the lab, you do your lab, you submit it that Wednesday. So the multiple choice, does everyone have like devices that they can bring on Monday or no? Because it was either do multiple choice online or do a written final. So anyway, we'll assess that when we get there. So I might just have an online multiple choice and you do it at home, and then you come in on Wednesday, the final week, and do the lab. Okay, so, all right. So Git, well, first let's look at the schedule. So somebody mentioned Thanksgiving, so yeah, we won't have lab on the week of the 23rd. So the 23rd we have off. So homework 3 will be due somewhere around there. And then you'll have your final on the 28th and 30th. Yeah, the 30th. 28th and 30th. So, okay. So, other things. So if you didn't finish Lab 08 from last week, it's due tonight. So try to turn that in if you haven't turned it in already. The homework for this week is due on Friday. So you got 4 days. So like I said, it should take you but maybe an hour of your time to look at the script and kind of explain what it does in comments as well as text. And yeah, so there's the assignment and there's the solution for Lab 7 that you need to look over, read through, and comment and everything like that. Any questions about the homework? Do you know what I'm wanting from it? Have you read it? So for those who have not looked at the homework yet, all I did is give you the solution for Lab 7, which was the biscuits lab. And it has some slight differences, not anything really major, but it's got a couple slight differences. So you'll download the Lab 7 file, the solution. You'll extract the files with the tar command. Then you'll go into the directory, and then you'll edit each of the scripts in the makefile, and in each of those files, you'll put comments over each line saying what they do. So you'll say little short comments, like if it has make directory, it says create directory XYZ as a comment with the pound sign. So you shouldn't change the script content itself. You just put a hashtag or a pound sign, and you put this line does this, this line does this, this line does this. You're just commenting or documenting what the actual script does. After you've done that for all of the files, you'll save those files, and then you'll create a short little README file that has just a high-level overall summary of what the script does. And then you'll put all that inside of that Lab 07 directory. You'll rename it with your username in front of it, and then you'll tarball it and submit it. That's it. So short summary, comment the solution, submit it. Done. Right. So not too bad. So that's due Friday at 11:59 p.m. And yeah, so that's it for the homework. And just, again, we won't have any more required labs. I'll have a makeup lab. So just come for the quizzes on Wednesdays, and then you're done for the week as far as lab. Because we've done 9 labs this semester, so I think that's enough. I think that's more than enough. So, okay. So, what does Git do? It's version control and collaboration. Git's just another program that you're used to on the command line. So it's got multiple options, different things you can add to it to make it do different things. You've got all these different clients or servers, whatever you want to call them. that just use Git. So GitHub, GitLab, Bitbucket all kind of do a similar thing. They help with collaboration and version control. And it's really just because Git does everything under the hood that actually all these things do. These are just website versions of them, right? GitHub does this, GitLab, Bitbucket, they're all just web interfaces for Git. So they just host online Git repositories and help. And the major benefit of these online versions is because of collaboration. They make things easier to where people can work on projects together versus having to work locally and whatnot. So Git and GitHub and GitLab, alternatives of them, are used by companies everywhere. So if you get a job after this course or after college in software development or somewhere in computer science, you're most likely going to use Git somewhere. I think almost all companies that are sane when it comes to software development use some kind of version control or Git. So there's often a lot of Git that you don't need to memorize. You only need to memorize really a couple commands, but if you ever find yourself needing a new command or a different command, GitHub has this Git cheat sheet that you can go and get online. So it has all the things that you could probably pretty much ever use in GitHub. Like I said, you don't need to know this like the back of your hand, but if you ever don't know what you need, you can come reference to this and kind of help figure out what you need to do. So, okay. So, a couple Git basics that are just good general rules of thumb. Branches are like directories. So in Git, there's this concept of branches of code. And these branches have different copies of your code that you can work on at different times and without modifying the other branches. So you can kind of separate your branches out, let other people work on them without kind of having everyone trample all over one another. So think of branches like directories. They each have a copy or clone of the code that people can work on without necessarily modifying or messing each other up. So by default, the main branch or master branch is your default main primary branch. And the thing about the main or master branch is you never want to directly test and put unstable code on the main branch. It's just bad practice. Your main branch should always have your working, most recent, up-to-date, stable version of your code. You should never just work on your main branch and work on it and test new things. It's meant for a stable code base. Then you can take other branches from the main one and work on those, and that's fine. But don't ever work on your main branch. It becomes a pain for anyone that you're working with, and it's just bad practice. You want to have your main branch always be stable so that if you mess something up in the code, it doesn't ruin all your code and it just causes a huge hassle. All right, so I mentioned that GitHub is mainly for collaboration. So the online portal of GitHub or whatever just really helps you connect with other people and look at other people's code, help them with their implementations. You can do different things like fork your code. So if you fork a repo, it just basically copies their code. That way you have your own copy of it and you can work on it. You can create and submit pull requests. So if you ever go to the Linux kernel by Linus Torvalds, he's got a GitHub for Linux. You go in there, and if you're trying to implement something or help with the Linux development, you can implement something and then put in a pull request. And he'll either accept or deny it. And then you've contributed to the Linux kernel. So you can have your name go down in history as you contributed to Linux. This little tiny thing in Linux or big thing in Linux. So this is where a lot of people like to live on. They like to have GitHub as their hobby. They go and contribute on as many projects as they want, and then they're kind of known in the community that they help with open source software. So, okay, so let's do the homework one real quick. So I'm just going to go over what you did. So I'm going to do it on my Mac. All right. So the first thing we did in the homework was we set up our GitHub repo and account. So let's go ahead and do a new repo. So this is my public repo on GitHub, and I have it nice and fancy. You can edit this. You can have like a README that shows all these links and your dev tools, whatever. You can customize it, make it look nice. I have another little graph down here that shows how much I commit or how many issues I open, how many pull requests, whatnot. So yeah, you can make it like your own little personal website almost. Okay, so let's create a new repository. So I'm going to go to repositories, go to new, and I'm going to do homework. So CSCE 215 homework 01. I know it's supposed to be called dot files, but I already have a dot files. And we create the repo. All right. So once you've created the repo and set up your GitHub account, what you do is now you have to connect the command line to GitHub. So let's do that. So we go to our SSH directory. You'll notice I have a ton of different SSH keys. So I have one for my lab, I have one for Intel because we work with Intel, I have one for Lambda, I have one for a server at home, and I have some old keys or old configurations, whatnot, but I want to add to my configuration. So I'm going to just put a comment and say github.com. You don't have to do that, it's just so it's bookkeeping. And we want to say host github.com. So this says, hey, this key or this SSH configuration is for GitHub. All right, and then we put preferred authentications, and I spelled it wrong. All right, and then I do public key, which we'll discuss in a second, and then we'll do identity file, and then we do our home directory .ssh, and then GitHub, and then ID ed 25519. All right. So now we've set up the kind of like where the SSH key should be pointed to and what kind of authentication, where the key is, where the little like private key, public key pair should be stored at. So with this file, you don't just have to do stuff like GitHub and stuff. You can do one for the Linux labs too. So if I wanted to do something like the Linux labs, I could do 129.252.130.196. And then, you know how you enter SSH-P222 every time? You can just specify port 222. So anytime you enter this IP address, it automatically defaults to port 222 with the SSH command. So instead of having to write it every single time, you can do this. And then you say host name, you can add all kinds of different things to it. Anyway, so you can set up your configuration so you don't have to type it every single time. You can see I've set up some down here. You can even put your username. So my username for the university. And then every time I do SSH, so if I do SSH, DSC, I can also auto-complete it. So instead of having to type out the entire IP address for the Linux labs every time, since I have it in my config file, I just start typing it, I hit tab, and it auto-completes. And since I've put the port in there, it automatically says, okay, with this user at this IP address, I know to use that 222 port instead by default. So you don't have to enter port 222 because it's in your configuration. Anyway, so that's extra. All right, so let's create our directory GitHub. So we got a GitHub, go into GitHub, and now I'm going to create my key pairs. So in security, there's this thing called public-private keys, and they're basically really hard math that a computer can't solve without doing a ton of effort or spending a lifetime to compute. That's what public-private key cryptography kind of bases itself off of. You have a public key, which you can share with anyone, and it doesn't hurt anything. It lets them encrypt things and send messages to you. But the thing that you should never, absolutely never share is your private key. Your private key is like a password. If you give your private key to anyone, it's called private for a reason. They can take any of the messages you send with that public key can be decrypted. So your public key encrypts messages, and then your private key decrypts them. So any traffic you send over that's encrypted with that public key can be decrypted if you share your private key. So don't share your private key. So you're gonna do SSH keygen. And then there's tons of different public-private key algorithms for encryption. And one of the more stable or secure ones nowadays is this ED25519. So that's where that comes from. This is a public-private key algorithm, or public-private cryptography algorithm. Then we do the number of rounds. We can do anything, 213, and then we specify a file. All right, and then you can put a passphrase if you want to. On my machine, since this is my computer, I don't have to put one because my computer's already encrypted. But if you're doing this in the Linux labs, because those Linux labs computers are shared and IT administrators have access to it, they can look at your private key. So you want to use a passphrase on computers that are shared because some people could see it, your private key. So you want to use a passphrase on computers that you don't own. Otherwise, your private key can just be read. So this passphrase, all it does is it encrypts your private keys to where other people can't get it. But since this is my computer, I don't care because it's already encrypted. All right, so it gives you this, and then you're left with two files. You're given this pub file, which is your public key, and you're given this private key. So this is the thing you never share, this IDED. If you share it, you might as well throw these keys out again because your key, it's like giving your home key to everyone in the world. Like you don't want everyone having your house key or your apartment key and everything. You don't want to give that key away. So you'd never share this file. But this file, this public key, is perfectly fine to share. So we're going to cat the star.pub. So this is my public key. So when I post this lecture on YouTube, I don't have to worry about this. This is my public key. Anyone can have it. I don't care. They can't do anything with it other than send me messages that are encrypted. And only I can read those messages because I have the private key. Okay. So let's go to settings. And then SSH keys. We're going to do new SSH keys. And then we're going to say MacBook Pro, because this is my MacBook Pro. I paste my public key. I add the key there. And if anyone thinks that they're going to be sneaky with these, yeah, these are all going to get deleted. So have fun. I'm going to renew all these. Just go ahead and delete them now so I don't forget. So yeah, so if anyone online says, oh, I want to get their public key and try to figure out what their private key is somehow, then they just got deleted. I'm renewing them after this lecture. Same thing with this one. So anyway. All right, so now we have that set up. So we gave our public key to GitHub, and that essentially allows us to authenticate from the command line. All right, so let's go to our repos. I'm just going to create a new repo called CSCE 215 homework 01. I'm going to go into it. Oh, use my alias. CD CSCE 215, and I'm going to do to homework 1. All right. So now this is where you enter the things that GitHub tells you to enter for your repo. So if we go back a couple tabs to our repo, there we go. I don't necessarily remember these things like off of the top of my head. GitHub gives them to me, so I just copy them. So if I want to create a new repo, I just say, okay, I create a README. That's all that line is doing. It's just redirecting this output to a README, so it has something to push. Then we initialize GitHub, so we do git init. Sometimes they'll give you a warning. Don't worry about it. And then after that, you add everything that's inside of your file, your directory. So git -add or git add -all, and then you commit everything. So we say init commit, And then we set our branch name, the primary branch name, because by default, Git used to default it to main or master. I like main better because it's shorter, so we change it to main, the primary branch. And then we do this git add origin. So we just copy paste it, press enter. It adds this, hey, it says, hey, this GitHub repo points to this GitHub URL or GitHub place on GitHub. All right, and then push origin main. And then if we refresh this, then it pushed our README. All right, so that was homework 1. Like, that was it. You create the key pairs that allow you to authenticate with GitHub. You write something in a file. You push it to GitHub, right? So that's all you needed to do for homework 1, except for writing a short summary of what you did, and etc. All right. So now you have a repo. So now in here we can create our scripts. So if I want to create a short script, or let's add our tic-tac-toe game from last week. So CP, it's on my desktop. And if I look at it, it's PSC lab 01 solution to dot. And if I do my tar-z or xvf PSC, unzip all my code. And now if we do git diff, so diff just finds the differences between what was previously pushed to GitHub and what you've added. So if I write this, or actually I have to do git add. Now if I do git diff, maybe not. Diff. Nope. Okay. Git commit. Maybe it's when I have to commit it. Added tic-tac-toe game. I do this. Git diff. Nope. Okay. Interesting. Git push origin main. All right. So that pushes that git tic-tac-toe game. If we refresh again, there's our tic-tac-toe code. Go in this directory. Got our code. Got our header files, whatnot. And let's say I want to collaborate with somebody. Well, since this is public, anybody can see this code and then fork it. So if you want to fork it, you come up here and you can fork it. So if I click fork, it's probably not going to do anything because it's mine. Yeah, okay. So it lets me create a fork, and they can copy my code over and start working on it on their own without affecting my code. Okay, so that's one way somebody can contribute, or you can contribute. You can fork things. And then, okay, well, now we want to actually contribute something. So if you find an issue, like a bug or something like that in their code, and it's causing issues for you and you want to contribute, you can open up an issue. So if the Wi-Fi will cooperate, there we go. So you can create these new issues. You say new issue, and most repositories will have a template or something that says, hey, here's how you could actually open an issue, and you copy that template in and you do whatever they say you have to do, like the logs or whatnot. So come on, internet. Create a new issue. So he says bug in software. You leave a comment. I found a bug. And then you can like assign somebody if you're the administrator of the GitHub. You can also put a label to categorize what the bug is or what the issue is. All kinds of different things. And then you submit the new issue and it opens this issue. It says, I found a bug, and then you start going back and forth. It's like a chat room or like a comment box. So people can comment and say, hey, I found the issue. Yeah, you're right. There's an issue. And then you can go back and forth and fix it, figure out how to fix it. And then when you're done, you close the issue and it's done. Like it's closed. It's no longer an issue. You fixed it. Right. All right. So that's issues. So if you're working on a project with your classmates or something in the next class and something's broken, or if you need something implemented, you can open up an issue and say, hey, this needs to be fixed. You can specify where it is. There's all kinds of fancy things that GitHub does to point at different parts of code and whatnot. Okay, so then there's pull request. We'll see that in a second. The really cool thing about this is, especially for class projects, you can keep track of who did what. So if you're using a GitHub repo with you and your teammates, you can come to this Insights tab and look at contributors. So if you have your classmates in this GitHub repo, it actually tracks who did what. And if somebody's not pulling their weight in the class, you can show this GitHub to your professor or somebody like that and say, hey, I did this. This, and this, and this, and they can see what you did. So it kind of backs you up a little bit. And it takes a little while. I think it's because the Wi-Fi. Yeah, so it shows something like this. It has 131 additions, 0 deletions. So, yeah, and then it would show a different card if somebody else was here. Okay, so let's do branches real quick. So this is my main branch. This is where my primary stable code lies that I don't want to modify. So this main branch is like, okay, this is what I'm letting people use, right? It's the stable version, it works, I know it works. So let's say I want to test something or create something new, like a new feature. Then I can create a new branch in the GUI, or you can create it on the command line. So let's do it. So if I do git branch, it shows that I'm on the main branch right now. But if I do git checkout -b, and I can say new feature, it switches me to a new branch. So if I do git branch again, it says I'm on new feature branch, which right now it's synced with the main branch. So the main branch and this new feature branch are the exact same thing. There's no difference. But now if I do something like touch new branch, let's say finishing or new readme maybe, .md, and I go into the new readme and edit it and say, this is a new branch. I save it, and then I do git add --all, git commit -m, added a new readme, just say, hey, this is what I did. And then I say, okay, I'm happy with it. I want to create the new branch on GitHub. I say git push origin, but instead of saying main this time, I'm pushing it to a new branch. So I say the new branch name, so it's new feature. All right, so we just pushed the new branch. So if I go here to my code, GitHub is smart enough and it says, hey, I received a new branch right here. But you notice that it doesn't have that new file there, right? It's because we were on a different branch. So that new README file that we just created, it's not here on this main branch. But we can go to here and click on this other branch, this new feature branch. And there it is. There's our new file. So now we have basically 2 directories of code. We have one that's on one branch and one that's on the other. And it has our content that we typed in. All right. So now, to help us visualize what this branch looks like, if we go to this network thing right here, it's got our branches. So you can see that this is our main branch. Let me zoom in a little bit. So this is our main branch right here. You see it says main. And then I created a new branch that's new feature. And this new feature branch is ahead of one commit ahead of the main branch. So it's like, think of a tree, right? From left to right, that's what a tree. You're gonna have a bunch of branches and whatnot. So we created this new feature branch and we committed something on it. Okay, let's say we wanna merge in this new branch. So if we go to command line again and we do git, so now we're on a new feature branch. If we wanna merge that into our main branch, then we can merge it in via a pull request. So I'm going to show you how to do it in the GUI because that's the easiest way, but you can do it with the command line too. And this is how you would collaborate. So you go to your code, and you say, okay, well, I've got this new branch, and I'm going to do a compare and pull request. And GitHub automatically checks to make sure that it's a valid merge, so you don't have things like competing to merge at once. Create the pull request. And then it checks, does some more checks. And then you say merge pull request. All right, and then it closes this pull request because it merged in. So now, if we go to our code, our main branch now has everything that was added or implemented on our on our feature branch. So we merged that branch in, and now we have this new README file. And if we go to our insights again, go to network, not dependency graph, network, we can see, if we zoom in a little bit, that we had this new branch or new feature branch, and it merged it into main. So now main and new branch are the exact same thing again. Okay. So you branched off. You had two different sets of code, and then you merged them back together. Okay. So that's branching and merging things together. So if you're working on a project, say this person's going to create the game tic-tac-toe. This person's going to make the GUI for tic-tac-toe. This person's going to create the documentation. Each of you can have separate branches working on your different sets of code. And at the end, all you have to do is merge all of them together, and then you're done. Because Git is smart enough to know, normally smart enough how to know, how to merge things together without trampling all over each other's work. So yeah, so that's GitHub. You won't necessarily have to do all these collaborative steps in your next homework, but they're good to know, and you can use them. I would advise you to do some of the branching stuff, like on your next homework. That way you don't mess anything up. You can always have a copy of it in another branch, and you can work on that branch, and once you're happy with it, you can merge it in. But your next homework, so this brings me to the next slide, is going to be creating your own vimrc, your own bash RC, and your own scripts or whatnot that you want to set up. I'm going to give you a couple, and you're going to add them to your .dot files directory. You're going to create a make file, and that make file is going to run your setup scripts and also put your vimrc where it needs to go. It's in your home directory. And then it's going to create your own bash RC and import it into your bash RC that already exists. And then you'll have some customizations. So that'll be the next homework. After this week, it'll be due after this week. So it'll be due like sometime next week or the end of next week or maybe even a week and a half from now. Okay, and then so next week I'm gonna install Linux in here. I'll have everything, show you how to install it, how to set it up, what the common problems are. Have fun if you have an NVIDIA graphics card. Yeah, you're gonna have fun. Just gonna go ahead and warn you, if you have NVIDIA, you're gonna have fun with that. And then we're gonna go over some aliases, functions, environment variables, some of the operating system topics, rather than computer science topics. So.